So hey everyone, in today's video we're going to talk about indices, and I have written here indices part 1 because there will be more than 5 videos in a series of this single chapter only. In this part we are just I think there will be 8 9 videos, almost 10 also, I don't know, because it is the topic that can from easy we will try to cover it from easier to the hardest level. Okay, so in this video we will just going to learn about the basics, what is indices, what are the rules for solving indices questions, and in our next video probably from next video we will start doing some easiest question, then slowly we will increase the hard level. Okay, we will slowly increase the level of the question. So yeah, there is that. Now let us understand about the indices part. Okay, what is indices? Why do we use indices? Where do we use indices? Then we have to understand that first. Okay, so indices is used, basically indices is used when there is a multiplication problem. When there is a multiplication problem that involves a repeated root or repeated factors. For example, suppose we have a factor, so we have to find a factors of 64. Suppose we have to find a factor of 64. So let us begin by finding it. 2 times 32 is 64, 2 times 16 is 32, 2 times 8 is 16, and 2 times 4 is 8. 2 times 2 is equals to 4. So while writing the factor of 64, you can see that this 2 is repeated. Yes or no? This 2 is repeated 6 times. So 2, 4, 5 and 6. So you can see here this 2, the same factor, is being repeated how many times? 6 times, right? So this will be a lengthy process to write all 6 together in a multiplied form, but it will be easier. You see, since this two is appearing 6 times, yes or no, so we can simply write it as 2 power 6, which also means the same. This means what? This 2 power 6 simply means we have to multiply this 2 to itself how many times? 6 times. That means this 2 will get multiplied to itself how many times? 6 times. So 3, 4, 5 and 6, right? So the result will be same. And while writing this, you can see there is a name given to each, this 6 and 2. So this 2 you are seeing over here, this part we will call it as a base. Okay, we will call it as a base, and this part, the 6 part, we will call it as an exponent. Okay, what we will call it? We will call it as an exponent, or we will call it as an index. Okay, we can also call it as a power, but we basically many of the time we use exponent and index. Okay, power, sorry. Now exponent and power you are familiar with, but now let's focus in this index part. Okay, why we are talking about index? Because the topic we are touching here is indices. Okay, so now what is index then? Index means, simply, index means the power. Okay, index means the power of to which a number is raised. That means index, this 6 means what? You can see here also, by seeing this number also, you can tell that index means a power to which a number is raised. That means this 2 is raised to what number? 6, right? So this 6 is a index. And if we are using a plural form of index, then we will call it as an indices. Okay, so index is nothing but a power to which a number is raised. Suppose if I write 2 power 4, that means what? This 2 is been raised to a number 4. So to a power 4, that means this 4 will be a index. Okay, so and the plural form of index is indices. Okay, now let's focus on the rules of solving indices questions. Let's do that. Okay, altogether basically there are 6 rules, and from those 6 rules you can make more. If you want to memorize more formula, then you can create your own, but basically there are 6. The first that we are going to talk is about the product law. The first law of indices is product law. Okay, product law. In this product law, what I will do is I will just take any two algebraic terms. Suppose I took a power m as one algebraic term, and another algebraic term as a power n. Okay, and when I put a multiplication sign or a product sign in between, then the result that I can write over here is a power m plus n. Now let's think about it. If the base is same, what we can see here is the base is same. Yes or no? What is here? the base is same and the power are different, the power might be the same also, it doesn't matter, the only thing matter here is the base. Okay, base is same, and if they are in multiplication, then their power will get what, added. Even if the power was different, even if it was m, again the power will also get added. So there is nothing to do with the power, but we have to keep focused in this base. If the base is same and they're in multiplication form, their power will get added. Okay, so for example, let's see a power a square into a power 3. So this means what, the power of this a will get added. So a power 2 plus 3 results what, a power 5. So this is our answer. So in a sense we can say that if the base is same and is in multiplication, then we can add the powers, okay, of these two algebraic terms. Now let's talk about the quotient law. But before talking about the quotient law of indices, now let's talk about the law of negative index. Okay, law of negative index. Negative index means negative power, negative exponent. Because negative index means what, exponent, so if I have a algebraic term a, and it is already clearly stating that the power is, the index is negative, that means here it should be a negative number. So if it is, so here you can see m is the index, yes or no, m is an exponent and a is a base, and m is a what, negative index. So if such is the case, if this is the case, then we can just, this simply means what, the reciprocal of a power m. Okay, so this is what I was going to talk about. A power minus m is equals to what, 1 by a power m. We can write this out. Okay, and if you want to write 1 by a power m, then it can be written as a power minus m. So these are the vice versa steps, vice versa cases. Okay, and also the second thing is, if you have a power m and you want to change it into the reciprocal also, if you want to change this m into a negative index, then you can simply do it by changing it into a denominator. Okay, a power negative m, by doing its reciprocal, by changing this number into its reciprocal, we can just change the index of this algebraic term. Okay, so simply a power minus m means 1 by a power m, and 1 by a power m can also be written as a power minus m. And if you want to change the index sign of an index, then you have to change the position. If it is in numerator, you have to take that into a denominator. Okay, so it will become negative m. If the number is in denominator, when you take into the numerator, then it will become what, again a positive, it will become a positive. Okay, so this is called a law of negative index. Now let's move to a quotient rule. Okay, now let's move to a quotient rule number 3. Quotient rule. Okay, quotient rule deals with the division, as we have seen above. Product law, in product law what happened was, the base was same and they were in multiplication, then power get added, right? So in this one, I take two algebraic terms, suppose a power m and a power n, same like this one, but they are in division now. Okay, they are in division. So this simply means what? This simply means a power m upon a power n. Yes or no? A power m upon a power n. Now, if I take this a power n to a numerator, this a power n is a denominator. Yes or no? If I take this a power n to the numerator, so it will become what? A power m into a power minus n, because we just learned the law of negative index. If we take this denominator to a numerator, it will the power, its index will get the sign of its index will get changed. If it is positive, it will become negative. If it is negative, then it will become positive. Now see, the base is same, right? The base is same, and they are in multiplication. Which law we have to use here? The first one, the product law. Base is same and they are in multiplication, no matter what is in the power. So according to our first rule, the power should get added, plus, and what is the power here? Next power is minus n. So this simply means a power m minus n. Okay, so what we learned over here was, if an algebraic terms, if two algebraic terms, same algebraic terms with same base, let's say that if two algebraic terms with same base are in division, then we can write as this. Okay, if a power m upon a power n is given, so this will be equals to what? A power m minus n. For example, 2 power 3 and 2 power 2 is here, then the solution will be 2 power 3 minus 2, which will be equals to 2 power 3 minus 2 means what? 1, and 2 power 1 is always 2, so this will be our answer. Okay, so this is about the quotient rule. Now let's move to the another one. Let's move to the number 4, that is power law of indices. Okay, number 4, that is equals to what? Power law of indices. Power law of indices. In this one, again, let me take an algebraic term which has a power m, okay, which has an exponent m. Now if I again give a power n to this algebraic term, so what it will become? This one I can write it as a power m into n, or simply a power mn. Okay, a power m was already there and I gave power n to it again, so the power will get the power of a and the whole power will get multiplied. Okay, so that the result will become a power mn. If we see a numeric example over here, so 2 power 2 and whole power 3 is given, right? So this is the same case. Now what will happen? This 2 power will get multiplied to itself. Okay, so 2 power 2 into 3, so it will become what? 2 power 6 will be our answer. Okay, now let's move to number 5. Let's move to rule number 5, which is equal to law of zero index, but I think I forgot to clear something more on this power law of indices. So I do have, suppose I have any two algebraic terms a and b, and the whole power of these two algebraic terms is m. Okay, so this means this m will be the power of a also, and m will be the power of b also. Why? Because there is a bracket given over here. There is a bracket, that means m is the power of both, m is the exponent of both, so our answer will be a power m into b power m. Okay, so this is how it works. And again, if a upon b whole power m is given, this case will be same. This m will be the power of a also, and this m will be the power of b also. So the result will be what? A power m upon b power m. But the thing that you have to focus here is this is applicable only for multiplication and division only, but not for addition or subtraction. For example, if I write a plus b whole power m, then you can't write like m is the power of a also and b is the power m is the power of b also. You can't write in this case like this. Okay, this will be totally wrong. You can't just write like that. Okay, this is the case. This is applicable only when the algebraic terms are in multiplication or in division, not when there is a plus, or not when there is a minus in between the algebraic terms. Okay, if a minus b whole power m is given, you can't write a power m minus b power m. Okay, this will be wrong, right? So yeah, if there is a whole power, if there are two algebraic terms and they are in multiplied form to each other and the whole power m is given to it, then we can write it as the a power m multiplied by b power m. Okay, now let's move to rule number 6. Rule number 6 is about law of zero index. Okay, law of zero index. Zero index means what? If zero index, okay, zero index, don't get confused with this word index. This means simply the exponent. This simply means power. Okay, if I have an algebraic term a with a power 0 in it, then I can write it as 1. Okay, I can write it as 1. If I do have any number 2 and it has a power of 0, then I can write it as what? 1. Okay, so this is how it works. Now I'm not going to discuss about why a power 0 is equals to 1. Okay, because that single thing will become the much lengthier video in it now. So let us just, okay, I will give a short hint. A power 0 means what? A power x minus x, right? A power x minus x is equals to 0, and again a power x dot a power minus x, this and this means the same thing. Now let us write again a power x. By the law of negative index, a power minus x can be written as a power x, yes or no? And what we can do now is a power x and a power x will get cancelled, so what we have here is 1. So this is the value, okay? This is the shortcut way I have explained you. Now let's move to the rule number 7. Let us just scroll it up and write the rule number 7 or 6. 1 2 3. Okay, rule number 7. Rule number 7 is root law of indices. Root law of indices. Okay, so in this part what we are going to learn is about root laws. So suppose if I have a nth root of for an algorithm A, suppose I do have this one, okay, nth root of A. So this root can be changed in the form of a power 1 by n. Okay, this means the same thing. Suppose I do have a number 3 cube root, and I do have a number 2 inside the root. Okay, so what I can write over here is 2 power 1 upon 3, because in place of n what we have here 3. Okay, so it will become 1 upon 3. If we had 4 in place of 3, the result will be 2 power 1 by 4. So what will be the case for root under 2 then? What will be the case for root under 2? The case for here, there is no any number, so what? There will be no number in between, or what? No, there will be a number called 2. Why? Because this is a square root. This is a square root, so in power we can write it as an 1 by 2. Okay, so this is how we are going to solve. These are the some basic 7 rules. These are the 7 rules that we have to memorize, we have to understand thoroughly, so that we can apply it into the questions. All while solving the questions of indices, all these rules will apply together. Okay? You don't know how it will use, but you have to know whenever you have to use, just you should be able to use it. Okay, so if you haven't understood anything, then you can revise the video, rewind it, you can see it again, you can write down the formulas as well. If you haven't understood at once, try to see it 2-3 times, then I hope it will help. And in next video also, from next video we'll start solving questions actually. Okay, this was the part where we learned about the rules and indices. Okay, from next video we'll start solving questions, so stay tuned. This is the part 1. Don't forget to subscribe so that you will get notified when I put another videos on this topic, which is basically a part 2 one, and this is part 2. Okay, then stay tuned. Have a good day. Take care. Bye bye.